Sounds good. Hello everybody, my name is Lillian Goss-Perks. I am the project manager for Elk Construction Consultants, and today we will be going over our progress on the Amazon Industrial Park reconstruction project. With me today I have Chance Troxa, Chris Wang, Elizabeth Walker, and Caitlin Frank, and we will be going over our various responsibilities for this project. I am the transportation lead for Elk CC, and today I will be describing my alternatives for you and the processes leading up to that and what we will be doing next. So for the scope of work, it mainly is centered around this new connector that will be connecting County Road 4, which you can see there, County Road 19, and then the toll road entrance. There's also another auxiliary road, which is County Road 17, which is this north to south road right here. The general alignment will be from east to west of County Road 19, and it is important that it gives access to the location of the building that we will be adding. And part of the scope is this, there will be a signalized intersection with the Indiana Toll Road entrance or County Road 4, and the other intersection will be a stop control intersection with the new connector to County Road 15. The scope of the transportation engineering also includes any access or parking lot work. So for my design criteria, I'm mainly using the Indiana Design Manual. There will also be some supplementation from the Ashland Green Book. However, the two criteria are mainly the same, so it will not be that different. If you have any questions on that, I'll take those questions later. However, this is more for the design components later on, not rather than like the alternatives which we'll be talking about today. So I have two main alignment alternatives, A and B. This is alignment A, which has a more curved location up where we'll connect into County Road 4 and 17. And then we'll go curve down to where our building will be, which is approximately this area. And then it will connect into County Road 4 near the building. The other alignment will just be more of an east to west straight shot between County Road 17 and County Road 19 on the other side. And it will also connect into there's a parking lot right of this, which is outside of our scope of work. However, it will be easier to have an intersection there rather than anywhere else on the line and to have more stoppages on the toll road entrance. So within these alignment alternatives, I'll have different considerations for lane configurations at these intersections, which is the main alignment alternatives for these designs. I have some preliminary looking at for the lane configurations. However, that will also be based on traffic count data and turning movements, which will be at a later step. There will be, for this alignment A, there will not be any changes probably made for lane configuration at the intersection with County Road, the new connector to the toll road. However, for the other lane configuration, which was just the east to west straight shot, there will be probably different lane configurations at both ends, depending on how the turning movement is affected by the lane configuration, as well as any access we may have with the building, because we will be doing a warehouse. So there will be a lot of truck movement. For future work, I will be completing parking lot and access routes, especially as they pertain to trucks for the warehouse building and any other auxiliaries such as water treatment, etc. facilities. And I'll be using traffic count analysis to help me make my decision about which alternatives and lane configurations are best. And then I will also be working on my vertical alignments to help minimize the cut and fill for the alternatives. After that, I will be handing it over to Chance.
Thank you, Lily. As Lily introduced me, my name is Chance Troxa. I'm responsible for the structural portion of the Amazon Park redevelopment in Elkhart. So first, my scope of work. I was tasked with building or designing the building for the industrial park. I opted to go with a warehouse just for functionality. This warehouse includes office space, loading and unloading space, as well as other spaces for upstairs. We had to determine the appropriate loadings after doing this, based on the offices and other loadings that will be applied to the building. We additionally had to determine the location. So as you can see on your right here, I located it near the roundabout. As our transportation engineer just indicated, we're going to have an access road, providing easy access for trucks and other vehicles to get there. After that, I also had to obey the local building codes, just so we have a structurally sound building that's not going to collapse. Additionally, I had to develop alternative options. As you're going to see, we have 3 different options coming up, and then we're going to, at the end, conduct an analysis and make a logical decision as to which one is best. Finally, part of what goes into that is going to be determining the cost of those alternatives, which again is going to determine which one we select in the end. So live loads. So in this table, this is the expected live loads on the building. As I mentioned, we're having offices, reception areas, warehouse storage spaces, and docks. We additionally took into account roof and snow, and we for sure took into account lateral loads to ensure no wind issues. So here's my first floor plan. So what you're going to see in the next two slides are two different floor plans. I have three alternatives, two of which are two-story alternatives, and the third one is a one-story alternative. This floor plan you're looking at here is applicable to both two-story alternatives, both here coming up. So on the first floor we have our storage space as well as our loading and unloading space. Why do we do that? Because there's no point in having storage space upstairs where people would have to haul things upstairs and it just would not be convenient. Upstairs it made more sense to have our offices and hallways where realistically there's not going to be heavy loads being hauled upstairs, it's just going to be offices and things like that. But then we have our one-story alternative. As you can see here, it's the same things, right? So we still have our loading spaces, we still have our storage space, we still have our offices, except in this case, it's all on the main floor. An advantage to going this route is that we avoid any ADA complications because it's all one level, we don't have to deal with an elevator, none of that, it's all on the ground floor. However, the disadvantage is that we would be using 35,000 square feet of flat space on the ground as opposed to the first floor plan you saw, which is 17,500. So alternative one is our two-story reinforced concrete alternative. In this alternative, everything is reinforced concrete. Roof beams, slabs, foundations, columns, it's all reinforced concrete. The advantage to that, concrete is very good in compression. So when we have heavy loadings from a warehouse, we wouldn't have to worry about it because it'll be able to handle the compressive loading. The disadvantage is that concrete typically is more expensive. Again, we don't have that quite proven yet. That'll happen in the cost analysis in the future, but that's something to be concerned about. On your right, that's the layout of the beams expected. This is subject to change upon the design 2 phase, but this is just a theoretical layout we're going to use to calculate our costs. Next up, we have the two-story steel alternative. You'll notice really no change in table beam layout or anything like that. It's the same number of beams, except in this case, everything is connected and everything's made of steel, except for the slab. Actually, in all three alternatives, our slab is going to be reinforced concrete. As I mentioned before, it just is good in compression. The advantage to steel is that typically it's prefabricated, meaning you can bolt and weld it on site, which is typically a money saver. And it's also very good in tension, which is good at resisting those lateral loads I was referring to earlier. Finally, we have our one-story steel alternative, again with a reinforced concrete slab. There's really no other advantages I didn't mention about steel that apply to this other than that it's one story. You'll notice this table has a different number of beams. Mostly that's to do with the perimeter beams, given that it's a box-shaped structure as opposed to a vertical structure. We needed to have a different number of perimeter beams to make the structure actually work. So then future work, I have to determine what beams are actually going to be used in each alternative so I can determine the appropriate cost and dead loads associated with them. Again, I have to determine the dead loads after doing that so we know how much self-weight is there and how much loads are actually going to be applied to each building. After doing that, we can complete the costs and then we can choose an alternative. Some of that alternative selection will be based on cost, but it'll also have to do with real estate confinement, environmental factors, and other things that come into play. With that, I'll be handing it to our water resources engineer, Chris Wang.
Forgive my poor English. This is Chris, and my part is water resources. And here's my scope of work. First one, I need to determine the watershed, which means I need to know the direction of water. Second, I need to calculate a flood control volume and water quality volume. And then I need to determine the location of BMP, which is next to the roads, and some of BMP should be in the, like most of BMP should be in the lot that Best Buy is giving. And finally, eventually, I need to make sure that all of it are obey the local regulations. And here's my water quality volume calculations. Due to the required, it says that 1.25 inch per square feet. And like Lily gave me the length and width of the roads, and roughly area of the parking lot, and I get a area of the building from James, so I get a roughly water quality volume of them, and that's the water quality volume calculations. And then we got a stormwater storage calculations, and I'm using a method from the data and the data in the regulations, which is like it gives me the intensity and storm durations, and I can calculate the inflow rates. And but like my coefficients, which is C, it's like a roughly estimate because I don't have the real type of surveys, and exactly area, but like after that, the outflow rate is also given. So I can get finally I can get the required storage. So we can get that eventually at the 24 hours durations. It has the biggest required storage, and that's the data I can get. After I get the exactly area, the data, I will get the right required storage, and that's for flow control, flow control system. And that's my watershed, and that's the road of our site. That's the location of our building, and that's my watershed. It shows that water goes inside, and from my side, it's basically the direction is from north to the south, but it has a little bit difference inside, but basically it's north to south. And then I also did some investigation of my alternatives. One is in Africa, the most soil type is alkali, serious soils, which is so loose, well drained, deep, and which means it has a high infiltration rate. And after research and the meeting with the Professor Wise, I get that it's pretty fit to use vegetative wells and infiltration change. That would be the sum of good choice. And here is the like classic combination. You guys are heard that. The detention ponds and rain garden. I'm gonna do this design first for this combination, and that's my future work, which is I still need to do some area calculation about pervious and impervious area, and then determine the exactly location of my BMPs. And also I need to determine the location like next to roads, and I also need to design the type of BMP, depth, width, length, something, and eventually I go for an alternative to do next one is
Hi, my name is Elizabeth Walker. I'm one of the environmental engineers for LCC, and my responsibility is wastewater. So my scope is to design a wastewater treatment facility to treat 1 million gallons of water per day. Included in this is the determination of biological treatment alternatives and the cost analysis of those alternatives, as well as making sure that everything is up to code. Here in this image is the proposed location of the wastewater treatment facility. So my first alternative is activated sludge. This is the conventional wastewater treatment often used for municipal locations. And it's for good reason, because it has a very high efficiency of about 90 to 95% BOD removal. That's biochemical oxygen demand. This type of treatment does use a high constant energy. That's because the pumps need to be injecting air into the mixed liquors at all times to make sure that the bacteria are doing their job. This treatment requires skilled personnel to operate and to maintain, and it also takes up a larger space. My second alternative is the trickling filter. This is a lower maintenance passive treatment, quite reliable. It has a lower energy usage than the conventional activated sludge. And these type of treatments are able to withstand shock loadings from industrial effluent, which is a benefit at the Amazon industrial site. They do have a bit of an odor, which will be fine because we're not really near any residential areas. And one thing about this treatment is there is a higher initial investment, but that sets the road open for a lower long-term cost. My third alternative is the rotating biological contactor. These have a much lower space requirement. They're very compact, and they also use a lower energy than activated sludge does. These treatments must be covered to protect from the elements. They don't fare well in cold temperatures. If they're frozen, then they're not working. And we also want to keep them covered to make sure that they don't have any human contact. We don't want people walking up, getting their hands in wastewater mid-treatment. So my future work is going to include the calculation of required flow values. And with these values, I'm going to begin the designs for the pre-treatment components, such as bar racks, channels, grid chambers, whatnot.
I'm going to continue narrowing down the alternatives and performing cost analysis to help me do so. And with that, I will turn this over to Caitlin.
Hello everyone, my name is Caitlin Frank and I am the second environmental engineer, a part of ELK CC and their team on this project. My scope of work does include designing a water treatment facility to treat 1 million gallons of water per day. This is for drinking water. Along with this, I need to determine the location of the facility, the water source alternatives. I need to design according to local codes and determine the cost of these alternatives. The two main sources that I will be focusing on with my alternatives include groundwater and surface water. So the proposed locations are listed on the board above you. The groundwater treatment facility is proposed to be in the northwest corner of the property, while the surface water treatment facility would be to the west of the building. Alternative 1 is a surface water source. This would be taking water out of St. Joseph River, which is located south of the project area. It has high flow quantities, and then some really bad water quality characteristics, which include pollutant sources such as failing on-site septic systems, direct discharge of septic tank influent. With increased development, there's typically pollution that gets into the water from that, and then agricultural practices can also affect the quality of this water. It is also far in proximity from the proposed location, so this would require a culvert inlet and pipe connection system to the facility for connection. My second alternative is another surface water source, which is Heaton Lake. This one is closer in proximity to the proposed water facility than the St. Joseph River is. It also does discharge into the St. Joseph River. This would require a culvert inlet with pipe connection systems to the facility. It is a consistent water source, but it does also have the pollutant source of existing on-site wastewater disposal. So this is an example of what a conventional surface water treatment train would look like. The surface water is the intake. It typically goes through a screen, some sort of rapid mix and flocculation, sedimentation, as well as a filter before disinfection into storage. So they tend to be longer trains than groundwater facilities are. Moving on to my third alternative, which is a groundwater source. The inlet structure for this would be a well on site directly on the project area. That is the facility located in the northwest corner of the projected area. A good thing about this is that all of Elkhart's existing drinking water already comes from groundwater. Two ways that we can take this is either connecting to the existing systems that the city already has. They have 3 well systems set up, which you can connect to piping, or we could do a private well installation on the property. In order to do this, we need to do an examination of the land conditions, which is a requirement. And then a good thing about this as well is the fact that groundwater has low turbidity, so it would require less treatment, but it does have high water hardness levels, which is why we have to stress water softening treatments. This is an example of a conventional groundwater softening treatment train. It is a little bit shorter, and after discussing with Professor Aljabe, with the facility only treating 1 million gallons of water per day, we would typically settle for a softening basin and then a storage tank after that. So it shouldn't have to be this long, and it will save cost. My future work includes the determination of treatment train alternatives. In order to do this, I will be evaluating qualities such as yield, water quality, land availability, transport, and cost. I will also be designing fire protection for the projected area, and then final cost estimates of these alternatives. And I will be turning things over to Chance to give you guys a cost estimate of the project.
Thank you, Caitlin. So here's our broken down cost estimate. To make things more visually appealing, we opted to go with an hourly rate that already included all the overhead and other cost expenses that will need to be taken into play. And we broke this down by discipline just to make it easy for the viewer. So you'll see that's the broken down discipline cost, and at the end we have a cost of roughly $77,000 for all of us combined to get the project done. With that, we'd be happy to take any questions from you all. Yes, sir.
I think this is a big ignorance question in Indiana. have you tested what is the allowable withdrawal of water from the rivers in Indiana? Have you already found out that?
I did some research on the information, but there is no information given on the allowable withdrawal from the river just because they do take all of their drinking water from groundwater sources, so I will have to look further into that.
I believe that in other states, you need to get a permit no matter where you get it.
Yes,
from.
correct. You also need permits for groundwater too, though, but that is unfortunately outside of our scope, so I do not have to look into that.
Yes, sir.
Speaking as a transportation engineer, Elizabeth, what is a shock loading?
A shock loading would be in an industrial environment, for example, where they're giving out like really heavy loads of pollutants all at once and then kind of lessening off. So it's taking like a huge amount of pollutants and able to treat it in a very short amount of time, as opposed to not a shock loading, which would be like a constant rate of pollutants.
Yes, sir.
So a question for Caitlin and Chris. So Caitlin, you mentioned at least your first two alternatives, like culvert design and getting the water out. So is that in your scope, or is that going to be in the water scope, or is that like not in your project?
It is allowed to be in my scope, but it can also be included in Chris's scope, so depending on which alternative we ultimately decide, that will be a discussion that we have to have on who's going to design that.
But if it is needed, someone is going to design it?
Yes,
Okay,
yeah.
just curious. Sounds like fun.
You.
Any other questions?
Yeah, I have Caitlin and Elizabeth. What are the relative space requirements of your alternatives? I know this is like alternative one is twice as big as alternative two, or how?
So for mine specifically, if I decide to go the surface water route, it will be roughly twice as big, just because groundwater, typically most of that treatment is going to be underground. It doesn't need a lot of land space. I have not gone into exact numbers yet. That's going to depend on the treatment train that I ultimately decide will be the best for the land.
Yours.
My answer is similar. It's going to depend on which treatment alternative I decide on, because the activated sludge takes up a lot more area than the trickling filter, for example. I don't have a number at this time.
Yes, sir.
Indiana has something that is called the setback for odor emissions. That is applied to CAFOs, confined animal operation, and for this source of odors. Have you checked into that? The setback. Setback means how far can the next residence be close to the plant in case that you select to use the trickling filter.
Are you talking about the distance between like the wastewater facility and the water facility?
No, I'm talking about the setback refers is you are going to be affecting any residential that is close by with the odors.
Because of the location of where we're at, there's really not a lot of residential areas nearby because we're right by a highway, right? So we're right by the toll road. So any odors or any other discharges from the treatment plants aren't really going to be a factor because we're right by a highway, so we don't really have to deal with any residential concerns.
So the closest town is far away.
It's just Elkhart's a very unincorporated area, and where this is at, there's really no concern of houses nearby because it's right by a highway.
Okay.
There is farmland nearby, but I don't think we're going to be close enough to any residential areas that it's going to be impacting them. And from personal experience, I've witnessed wastewater treatment plants which were closer to residential areas than ours will.
The point comes important when you are going to use the trickling filter. Yes.
Right.
The other ones, no. Yes. The activated sludge is yes, it's very common in residential environments. The yield, I know that you are calculating the yield, but have you figured out what is the yield, or not calculation about the yield
Not
from
yet.
the river?
That is
Or
not
the
yet.
yield from the allowable yield from the lake?
That is not yet determined at this time.
All right, well, thank you, everybody, for going over that.